So I'm now going to present how my development of FASMLIB library goes. First, you may remember my speech about what I want FASMLIB to be about a year ago. I think most of that was accomplished, but things changed many times. I rewrote some parts even 2 or 3 times, which I believe is good. So now this presentation will be also for those who don't know the project and haven't seen last year's presentation. So I will start with explaining what was my goal. First goal was that I realized assembly programming is portable over different platforms or operating systems as long as CPU stays the same. But there is problem with library because even if CPU is same, libraries from higher level languages like standard C library would be different even on same CPU. For example, on 64-bit CPUs, GNU library uses 64-bit form type long, and Microsoft standard C implementation of standard C library uses 32 bits.
Is that light bothering?
So there really isn't some processor level compatibility even between implementations of same standard on same processor. For that reason, I thought it would be nice, maybe not that useful for real-world programming, but there was certainly a gap of some library for assembly missing, which would be at least so portable as it is possible for assembly. Next thing I wanted was to make library usable easily in pure assembly without enforcing any macros on users of library. That also allowed me to easily port library for different assemblers or assembly compilers. And many people dislike macros, and there are also some new abstraction. I wanted to make library for pure assembly. Of course, we are talking about x86 processors, CPUs. And third design goal was that library was not intended to be fast, because what should be fast, you shouldn't use library at all for things that need to be fast. So it was more designed to be as safe as possible. For example, checking all wrong arguments someone passes or wrong pointers. And so library isn't really somehow fast. I did few tests and it was comparable to standard C library in things which could be already compared. But it is very safe to use and catches many program errors. Now, for now, I support 32-bit Windowses by using Windows Application Programming Interface and Linux kernel 32-bit version, but by using system calls. For future, I also plan a version which will run on standard C library, which will be nice for portability. And also system calls are a way which shouldn't be used when programming for Linux. Everyone is discouraging it, even Linux developers. Now, in current state, library comes in these formats. There are 2 object forms where entire library is in one object file that you can link. There is Microsoft's COF object, the one used by Visual Studio or Mason, for example. And for Linux, there is ELF object. Then for Windows platform, I also provide a library, which is different from object in a way that only parts of FASMLIB which are actually referenced but when you use library, only parts which you use and also parts which are used by parts you use and so are linked. And as last thing, it's a dynamic link library. It's not shareable yet because I didn't see that as very important. It was just very easy to do this format, so I did it. Then for FASM users, they can include FASMLIB by including its sources directly, so they don't have to do over the object form and link. Most FASM projects are done this way. That project is compiled directly into executable. Of course, compilation takes a little bit longer because FASMLIB has about 300 kilobytes of sources now, and there are some macros used for declaration of procedures and for declaration of data. Then for other assemblers, I have prepared headers for MESM with correct type checking and headers for NASM and YASM. Of headers for NASM have a problem, which is in fact NASM's problem, that entire library is always included, but that is problem of NASM assembler. It's not possible to do otherwise. And also I provide of those two Windows object forms, COF and library. I provide two versions, one with names decorated as they are in FASM, that is name of module dot name of procedure. But I also provide version with MESM name decoration, that is underscore. All dots in names are translated to underscores because they are not valid in MESM and other assemblers. And also there is @ sign and sum of argument sizes. So it's all MESM name decorations generally. Next thing, how do you call a procedure of FASMLIB? Just a simple call is done by normal near call. There is no indirection needed or loading or anything. Arguments are passed on stack as is usual in reversed order. Every argument is 32 bits. In case it's effectively smaller, it has to be extended and the rest is ignored. Only the actual part is used. Return value is in EAX in case it is 32-bit number. Additional return values can be in overflow flag, zero flag, or sign flag. Or if return value is just a Boolean value, it can be in one of flags, depending on context. For example, when you are reading from file, overflow flag is returned as well in case you hit end of file marker before reading requested amount. So it's easier for your assembly to check it. Other registers are preserved, always, every, except case, very rare, when we are returning 64-bit value, that is returning in upper 32 bits in EDX and lower 32 bits in EAX. But otherwise, all other general purpose registers are preserved, and all other flags. Also, if there is procedure which does a comparison, like comparing strings, it not only returns equal, not equal, but it also sets these flags so that you can use conditional jumps after sign comparison, that is jump if greater, jump if lesser, jump if lesser or equal. That makes sense for sorting, for example. It is similar to string comparison in standard C library. No, it's not always useful, but it's nicer a little bit. Also, I have one procedure with variable number of arguments. I made a lot of trickery there to keep the same calling standard, so that on the return there is no stack revamping needed. Procedure finds out itself how much arguments were on stack, and calling is exactly the same. You just, one of first argument has to tell somehow how many other arguments there are. In my case, it is formatted output, and it can be found by reading the format string. Procedure finds out how many arguments that there are, and the code procedure removes them. So so there is no need to adjust stack pointer back after returning from procedure. Okay, let's move on. Error handling. People who read my posts know that I am quite keen on proper error handling, and I really don't like crashing applications, rather some error that says nothing. So every single procedure returns error status in carry flag. That means complete error checking, like you have with structured error handling, is possible just by doing one jump if carry after every call, which I think couldn't be made better in pure assembly. In case there was some error, EAX holds error code, and it can be easily translated to error string just with a single call. There is also possibility to set up custom error codes which will be handled by FASMLIB procedure which converts error number to error string. So you can use custom error codes together with FASMLIB error codes, and they behave same way. I'm limited to those because in fact FASMLIB error codes are number 1, 2, 3 or so, but custom error codes are pointers. So there was some special code needed to allow them. Now I will talk about the actual procedures or the code of library. First, not much to tell about it. Memory manipulation procedures. Copy supports overlapping copy, like mem_move from C language, not like mem_copy. That is, if you are copying data few bytes backward, I think, forward, then if you would do it normally, you would overwrite the following data before you read it. So in this case, it must be copied from back to start. This is just supported, and there is a finding of value in block of memory, which is again done by some more optimized algorithm. Can't remember the name now. It was a few months since I wrote it. Comparison of blocks of memory again returns the operator smaller, so you can sort them if someone ever needs that. And filling of memory with some pattern. Then there is dynamic memory called heap. FASMLIB has its own heap manager, but if operating system provides heap manager, FASMLIB uses that one, as that is more convenient and can be handled by other tools which work with the heap manager. For Linux, where you at the system code level you don't have any heap manager, so there is its own usual procedures: allocation, reallocation, freeing, and getting size of block. It does need some initialization before it's used, and after it's done, it should be uninitialized. In implementation, it is implemented as single block of memory, which is enlarging on need. This has its advantages and disadvantages. This is just implementation detail. There is 16 bytes overhead per one block of memory allocated. I really test everything possible I could when someone passes bad pointer to one of these procedures. So it really should help catching this kind of errors. In most cases it will catch it. But FASMLIB is designed so that you don't have to use dynamic memory at all if you don't like it. Even the buffering on streams, this will be covered later, can be all done with static buffers.
But can you tell me, how do you allocate the memory for the heap on Linux? Do you use the set break, or do you use memory mapped files to allocate the memory?
You mean how do I allocate the entire heap, or how do I allocate the big part?
Yeah, the big block for the heap.
In case of Linux, I use break, and on Windows, I use Windows heap handling. And on Linux, I use break. It isn't good because when you mix it with standard C library, it tries to use it too, and they fight together, but that is the way. I could have also used virtual allocation, but
you could use the mmap function that works with memory map files, but you could use that for
same
memory
as allocation. It's the same system code for allocating virtual memory and doing memory map. Okay, then there is a ASCII string library that is only 8-bit characters. It works with zero-terminated strings, which are in static buffer. That means a size of buffer must be given at compilation time and they cannot be extended. To every procedure which works with strings, you must always pass also the buffer size and will never access behind it. And it will check strings which will otherwise overflow. So with proper using, your strings will never overflow. You have concatenating strings, which is adding one string to another, concatenating character, comparing strings, copying one string into another buffer, inserting, finding length, finding substring, finding position of character in strings, and extracting substring from strings. And these are only for ASCII, that is American code, and doesn't work for European encodings like Middle European and so. This is compare case insensitive, converting to low case and converting to upcase. But they won't work for Middle European characters or Russian characters or these. Then there is conversion module. It just converts binary value to text or to string and backwards. It supports binary, byte, word, double word, and can convert it to decimal and hexadecimal yet. In virtual into a binary and floating point types. It has also support for signed numbers, and there are many options of padding with 0 or with space, or with display plus sign, or not with display plus sign, whatever you like. I think everything needed is there. Then there is a string interface. I used a typical object-oriented design for streams that allows to use same code for any type of stream. Stream is just something you read data from or write data to. It can be file, memory can be regarded as stream, or it can be socket, network connection, or it can be standard output or standard input. And if we encode this in object with a given interface for every type, then we can use same code to access any type of stream. And we don't have to create separate code for every kind. But this object orientation is abstracted from user. It still appears as if streamer just handles and you call procedures on that. So people don't have to bother with reading into virtual table and finding pointers and stuff. So currently implemented are the standard input and output streams, which is standard input, output, and standard error. And also there are few procedures which automatically use these streams, so you don't have to always pass them as argument pointer to these streams. It's usually more convenient because this will be so often used that such helper procedure will come handy. And if you don't like it, you just won't use it. Okay, I see I missed one part here. That is few textual functions. Sorry, this is not yet, I'm not yet talking about this. I forgot to write about one part, which is handing of text. That is things like reading a line, reading characters until some special character or from some list is given, or reading decimal number. These operate on streams, so you can use this on anything that is a stream, same procedure. There are plenty of them. Most basically needed stuff, I won't tell them from my head. Okay, so that was about what FASMLIB is now. Soon I will upload a latest version, which still lacks complete documentation, but it's almost complete, and you can take a look at it. I will post the link on chat. Okay, I also should mention what are future plans for FASMLIB. I don't yet have implemented file as a stream or memory as a stream, but that won't be a big problem. I guess it will be done very fast. I don't have command line processing, that will be a problem on Linux. I won't get into deeper details now. I want to make FASMLIB based on standard C library, which will make it portable virtually across any system which has it, any operating system. I plan some very basic Unicode support. Full support isn't really possible and is out of scope of this library. I plan to also implement into entire library exception handling, which should catch bad or invalid pointers or pointers to inaccessible area passed by users. Then this is not that important, and also give some procedures a shorter name to those which are most often used. Okay, that was all. And in case there were some questions.
Well, let's just wait a bit for the stream to catch up.
What?
Let's wait a bit for the stream to catch up. That's 20 seconds of latency.
Okay. So, where's the button? What? I don't understand.
0_1 asks,
Martin, is that a question?
0_1 is asking if it's possible to do any GUI stuff with FASMLIB.
FASMLIB, no, it won't be. And I don't want to place that into FASMLIB. FASMLIB is going to be a standard general purpose library, which should be as portable as possible. Writing portable graphical user interface is very hard and it decreases portability. For example, Dex4U was going to make a port for Dex operating system, which is command line based, and I really think this is out of scope of library. It doesn't belong there. There can be another library for that. Or recently there was a topic on FASM board regarding which one to use. I think for assembly only possibility is GNU toolkit.
And Hydrup is asking if you plan on implementing a regular expression handler.
I probably wouldn't do it myself, but it could, of course, be there.
I think there was a thread on the forum.
Yes, I remember there was some regular expression done.
Yeah.
Problem is that I would have to check the code if it really does all the error checking and handling, and I would have to make it following the FASML calling standard and checking myself if it really works 100% correctly, and if yes, of course I would be glad to implement it. I was already thinking about it, but I never got to doing this. If it would be in FASML calling standard, or it would be easily possible to convert it into the standard, then yes, it would be a nice addition. No more?
Well, let's just give them a second to catch up.
Okay.
Doesn't seem like there's any more questions.
Well, what about something like big number calculations and cryptography?
Big number calculations in cryptography is usually something that is intended to be fast, and such general purpose library with a lot of abstractions I think shouldn't be used. There already are plenty of good libraries. The only thing that I would place into FASMLIB would be maybe displaying or converting to and from big number, but handling itself, I think this is really the thing that needs to be done manually, not to use library. You see, I think this is important to tell. Purpose of library is to ease job of programmer in parts which are not important to subject of program. If someone is doing, let's say, cryptography, then the cryptographical parts really matters, but he must waste a lot of time with other things like parsing command line arguments, reading key files and this, but these are not important to him, and that is purpose of library to make these side things which are needed and could take a lot of time to do by himself. So this should be provided by library.
However, the same problem occurs sometimes in cryptography, that there are some very elementary algorithms like triple DES that you use all the time, and this is not something you are going to implement yourself as so important, but you have to use it. So it's very similar.
Well, in a way, you could say that a thing like big number operations is very fundamental, but you can construct different crypto systems using big numbers.
Personally, I would use Lipton Crypt, which is a C library, but very, very nice and clean written, but it isn't, FASMLIB isn't going to be a huge library. I would rather it made it more easier to maintain, to contain the really important stuff, and when that is done, tested and everything, I can add some additional but not so really needed stuff. I would have to maintain it, and implementing cryptography is hell. You have to be safe against timing attacks, and you have to do dummy stuff just so they cannot count how long it took you, because even based on that they can find out something.
Yeah,
that is really out of scope of the library.
Yeah, but it would be possible for other people to make compatible libraries just using the same standard.
Yes.
Yeah, that would be a good idea.
Yes,
Probably.
if it would. But I think there are already plenty of such libraries written. Only problem might be that you cannot use then FASM's compiling directly to executable, or you can use the dynamic link
Yes,
version.
but I also mean that you've got some really nice standard about how you call and how you return errors, etc. So it would be good if there were more libraries using the same standard.
For assembly, I agree. If they are only be used in assembly, then certainly.
Zero_1 is asking if FASMLIB will have efficient algorithms for general uses like sorting and things like that.
Yes, in later phase, I plan implementing some containers like lists, which is a list array with dynamic pointers, so you can easily insert and remove stuff. Karol could tell you about that. Then I plan to implement this list and also the sorts, but that is not so important. First I have to make the most basic stuff. I would say that what standard C library, you know, those something over 100 functions does, something like that, which is basically just adding those file memory streams and command line support and maybe the basics of Unicode. And then I will implement these things, but I regard them as extras.
I think it's nice that you're not just copying the C standard library, because it's so full of very bad things. And
one thing people really disliked, but I did it, was changing the format string for formatted output.
Yeah.
Because C format string doesn't make really much sense in assembly. Typing long for 64-bit number or keyword really doesn't. So that was, I tried to keep things compatible, but